Okay, online students, can you hear me clearly? Online students, can you hear me clearly? Okay, thank you. So I was waiting because today is the first day of the lesson. That's why I was waiting a bit. Hope everyone's here now. So I think we can start. Yeah. Malli, Minaga. Okay, so last week there were two papers for Thursday class and Sunday class. Both will be discussed next week. I'll let you know the dates. If you like, you can join physically. Otherwise, you can join online, or else you can watch the recording. So the last week there were two papers for the Sunday class and the Thursday class. There will be two paper discussions for the both papers. If you like, you can join both sessions, or else join the related one. And again, today also there was the same request about the weekly paper discussion. So about the weekly paper discussion, for the new students, what usually happens is from 145 to 245 attention. From 145 to 245 we have the weekly paper. Then usually from 3 to 6:30 we have the class. So we have to change the plans a bit. I think now schools will be starting and all. I need some clarity about what is the latest time that you can stay in the class. Why? The main reason is, I'm doing this for Sunday class also. My plan is, attention everyone, attention. My plan now is to give you the paper, in the before the class, then do the theory, then do the theory sessions, okay? Do the theory sessions. Then after that, maybe for an example, this is just an example because we have to change this after school starts. For an example, something like 145 to 245, 145 to 245, it's the normal class. Sorry, 145 to 245 paper. Then 3 to 6:30 theory class. Then maybe from 6:45 to 7:45, if possible, discussing the paper. So if you like, at 6:30 you can leave, and you can watch the recording later. You can watch the paper discussion recording later if you like. Or else you can, directly after the main class, you can have a 15 minutes break and stay to the paper discussion and go home. Because initially I was planning about having 2 days for this, but it would be easy this way, right? I know it's difficult to stay for long hours, but anyways, in the future you have to do that in A-levels. So it won't be a problem. So I hope it's easy, right? I hope it's easy to directly stay after the class and stay for the paper discussion. And anyways, if you can't stay, you can leave and watch the recording later of the paper discussion, okay? And another thing is, attention. Another thing is, that is the plan, but that's not the actual plan. The problem is we can't write the paper from 145 to 245. Let's discuss. I think still students are coming. So let's discuss this. The problem is still from 145 to 245 we can't write the paper. The problem is schools are starting. Then the whole plan will be shifted by 1 hour. Then I have the doubt whether it's too late for you guys to stay. Okay, that is the problem. Okay, that we have to discuss. Okay, towards the end of the class, let's discuss these things. And from next, because the reason to discuss the paper, main reason to discuss the paper, now it's easy because it's units and dimensions and measuring instruments. When it moves to mechanics, there will be a lot of doubts. There will be a lot of difficult questions to discuss. So in that case, it's good to discuss. That's why I'm starting to discuss the weekly paper. And I mean, you may understand like MCQs are not that difficult for you guys, even from last week's paper. I mean, the MCQs are not that difficult. I mean, yes, I mean, sometimes yes. But one of the main issues was you can't write a structured paper, right? You can't write proper answers for a structured paper. It reflects when we look into your papers. The main reason is we haven't practiced it, okay? We have never, I mean, we didn't write a structured or essay question in our weekly papers, right? So the practice matters. So from next week onwards, we'll be including 1 or 2 structured questions, essay questions in the weekly paper, okay? So that, I mean, the practice matters, okay? So MCQs you will be able to manage to a certain extent. The main reason is you have enough practice with MCQs now. But I mean, when it comes to structured essay, you can't handle yet. Why? Definitely you should practice, right? The practice is the most important fact here, okay? I mean, in A-levels, like it's like 10% skill and 90% practice, okay? It's for sure, it's like 10% your IQ and all, and other 90% it's from practice, okay? That's the nature of A-levels. I mean, it depends on the exam. If you talk about Olympiad, it's like 90% skill, 10% practice, something like that. Like different areas, yeah. So here in A-levels, it's like 90% your like practice, and only 10% would account for the skill and IQ you have, okay? So here what matters is practicing every day, going through a lot of questions, doing things like that, okay? So towards the end of the class, let's discuss the plan. The tutes are available in the Zoom chat, but I'll provide you a number so that you can contact that number to get the tutes. You can contact that number to get the tutes delivered. Online students, physical class students, you can get the tutes today. Yeah. So those are the messages I have from my side. Yeah. So I think we can continue. So today we are starting vectors. Malli, Minaga. The files. Okay. So today we are starting vectors. Like the first part of mechanics, I mean the mechanics is actually when we start like motion equations, okay? Mechanics usually starts. Okay, attention. What are vectors? What is a vector? Vector is, I mean, attention everyone, attention. There are different physical quantities. And some physical quantities are meaningless without certain aspects. For an example, your mass is maybe 50 kilograms. Meaningful, right? It's meaningful. The mass is 50 kilograms. This is a meaningful statement, right? No big issue there. Clear? The mass is 50 kilograms is a meaningful statement. But if I ask you to push this table 5 meters, or if I ask you to push this table 5 meters, is that meaningful? It's not meaningful. Why? Where? In which direction? See, if I ask you to push this table 5 meters, it's like not complete, right? Not complete. The final result is not complete. Why? The final result is not complete because like you don't know what is actually going to happen, right? That is meaningless without the direction. Okay, that is meaningless without the direction. So vectors are these kind of physical quantities which are meaningless without a direction. Clear? Vectors are these kind of physical quantities which are meaningless without a direction. Clear? So And I mean, it doesn't stop there, okay? We usually discuss up to this point. Later we are going to discuss the other parts, but I mean, it doesn't stop there. There are some physical quantities, they are meaningless with the magnitude and direction both. There are some physical quantities which are meaningless with the magnitude and direction both. For an example, force, force, force is meaningless, okay? Force is meaningless without what? The point of action. The point of action. Why? The reason is, you have this pencil like this. I apply 5 newtons towards that direction. If I apply the force here, it would move like this. If I apply the force here, it would try to rotate. See? If I apply the force in here, it would try to rotate in this direction. See? Based on the contact point. See? Based on the contact point, what's going to happen depends, right? Clear? So when it comes to a physical quantity like force, it's meaningless with magnitude and direction both sometimes. With magnitude and direction both, sometimes it's meaningless. To make it meaningful, you need the point of action, contact point. See? So there are different levels like this, and when the physics continues, we add more stuff into this, and to explain some physical quantities, sometimes you need more than 3 dimensions. Then you need like space, time, and all kind of like different scenarios. You need to explain some physical quantities. Okay, so it continues like this, but in this lesson what we are going to learn is vectors. So what is a vector? A physical quantity with a magnitude and direction. Okay, a physical quantity with a magnitude and direction. Okay, so talking about vectors, I mean, everything is included in your note. For online students, we'll provide a phone number. Minaga, provide that phone number to get Tute's and all Vishwa's number. We'll provide you a mobile number. You can contact that number to get the Tute's and all, and or to join the group or anything. Okay, you can use that number. So in your Tute, attention, in your Tute, from page in English medium Tute, from page 1 to 12. From page 1 to 12, it's actually the theory parts that you should usually write. I have included in the note these things in the note because I mean I can't wait until you write. Okay, so from page 1 to 12, page 1 to 12, this part is supposed to be in your note. Okay, I'm saving some time by printing them. Then the actual Tute starts at page 1 again. Actual Tute starts at page 1 again. There you can find the exercises and all. Clear? There you can find the exercise and all. Okay, so the first part of the Tute, so actually, if you like, you don't have to write anything. Everything is included here. First part, the theory points that you should write. Second part, the actual Tute with the exercises. Okay, that's how it works. Like if you like, it's better to write these things again. Okay, in your book. Okay, we are not. I mean, in your Tute, not the Tute, in your book. Okay, so just because some students remember things when they write them. Okay, so just don't blame me that you can't remember things because I printed everything. You always have the choice of going home and writing the note. Okay, so everything is printed. So you have the choice of going home and writing the note. Just don't tell me that I can't remember anything because I don't give a note in the class. The note is given in the class. You can go home and write that, okay, if you like. Okay, but if you can remember, just don't go through that trouble. So for some students, you can maybe take this part and create a short note. For some students, you can just take this part and underline. For some students, you can take this initial part and highlight. It's up to you. It's up to you, okay, based on how you remember things, okay. So usually you don't have to write anything, but just go through the Tute when I'm teaching, okay. So how do we, attention everyone, attention. So how do we represent a vector? How do we represent a vector or write a vector? There are different notations that we can use to represent a vector. One would be like this. If there's a vector that goes from point A to point B like this. If there's a vector which goes from point A to point B like this, we call this vector AB. We call this vector AB. This arrow indicates that this is a vector. Clear? This is vector AB. Clear? This means there's a vector which goes from point A to point B. Sometimes we use a letter to represent this A. And this is just a letter. We underline that to mention that it is a vector. Okay, so an underlined letter means a vector. When we are printing, when in printed format in your papers and all, sometimes without underlining they may highlight. Okay, sometimes without underlining they may highlight this. Okay, so there are different notations that we use to represent vectors. So when you have A and when you underline that, it represents the whole vector. So when it comes to the magnitude of the vector, that means if you need the magnitude only, okay, we use this notation. This is the magnitude of the vector. This is the magnitude of the vector. Clear? This represents, if you see this thing, it shows the magnitude of the vector. Clear? Or else you can use same thing, magnitude of this vector. Then you can write this thing as A. Clear? So the meaning of this is, this just a series of notations that I'm going to use. Okay, so the meaning here is this is vector A, and when you remove this underline, you get the magnitude of the vector A. Clear? You get the magnitude of the vector A. So these are a series of notations that we use to represent vectors. Clear? Then this goes from A to B. There's something called negative vector. What is the negative vector? Negative vector is the vector that goes in the opposite direction. Clear? Negative vector is the vector which goes in the opposite direction. Okay, negative vector means the vector with the same magnitude, but which goes in opposite direction. Clear? So the negative vector of a vector is the vector that goes in the opposite direction with the same magnitude. Clear? Clear? We call this the negative vector. So we can represent that like this, minus A underlined. Underlined A means the vector. Minus mark mentions that it's going in the opposite direction now. Clear? This is the negative vector. So we can write this different ways. You can write it like minus AB, minus A, or else the same thing you can write as BA. You don't have to like by heart these notations, just understand these things because the notations may change a bit from place to place. Just know all the possible notations, then you would understand any question. Okay, so this is minus AB. Minus AB you can write as BA, right? If you like. Minus AB means it's going from B to A. Clear? Clear? Okay. So these are the possible notations related to vectors. Now, next part is vector addition. I mean, we usually know numerical addition kind of stuff we know, right? What happens, what is 5 plus 2? What is 2 plus 3? We know these things, okay? Attention. But the problem is, when there's a direction included, you can't just add stuff, okay? When there's a direction included, this is the set of notations required for vectors. Now we are going to, we are just defining a domain of physics, okay? You have worked with numbers up to this point, you haven't worked with vectors. So now we introduce the symbols required to learn vectors. Now we are we are going to learn how to do calculations related to vectors. So in maths, you usually learn integration, differentiation, all. The same way you have vector integration, vector differentiation kind of stuff in the future, okay? If you are continuing in engineering domain, you have vector calculus like that. Everything we were learning related to numbers, you have in vectors. So it's another domain of physics, okay? So now we will learn how to do basic calculations related to vectors. So talking about the basic calculations, first thing we should do is addition, right? Okay. So what is addition? 2 plus 3 is 5 because there's no direction included. But it's not that simple when it comes to a vector, but still you can understand what is going to happen, right? Why? Assume you are here, you need to go from here to here. Okay? This is your home. Clear? You have paths or roads like this. You have roads like this. Okay? You have roads like this. So to go from A to B, what you should do is, first of all, go from A to C. It's one vector, right? AC is a vector. Going from A to C is a vector. Then you go from C to B. Then you go from C to B. You go from A to C first. Then you go from C to B. AC is a vector. CB is a vector. But what is the final result? What actually happened? What actually happened was you actually went from A to B, right? You actually went from A to B. That is the final result. So addition of vector AC and vector CB is vector AB, right? Addition of vector AC and vector CB is vector AC. Is that clear? Is that clear? So using this concept, okay, using this concept, we introduce the vector triangle law. Okay, so nothing new. Here also you understand what is happening, right? Using this concept, we introduce vector triangle law. What is the vector triangle? Vector triangle law mentions that if there's a vector like this and another vector like this, okay, you first take one vector, you draw it, and at the end point of the first vector, you start drawing the second vector. At the end point of the first vector, you start drawing the second vector. Clear? Then the resultant of these two vectors, or the addition of these two vectors, would be this. Clear? This is vector triangular law. Okay? When you represent two vectors as two sides of a triangle, the remaining side of the triangle will give you the resultant vector. Clear? This is vector triangle. Clear? So that is the basic method that we use to define vectors. Clear? That is the to add vectors. Clear? This is the basic way that we use to add vectors. So go to exercise 1. It's after page 12 of your Tute. After page 12, you can find again page 1. There you can find exercise 1. Everyone got the Tutes? Anyone who need Tutes? Anyone? Okay. And for online students, tutes are available in the Zoom chat. We'll provide the tutes again in the Zoom chat. Go to exercise 1. Try 1, 2, 5, and 7. So how the class is structured now is, I usually start with the simplest concept. I would take a lot of time to explain things because there are different students with different capacities. So I'll start and explain things slow and steady. But after that, towards the end of the class, I usually move to the difficult questions every day. So towards the end of the class, if you can't understand how I got the answer, then it's up to you to work on that, okay? Towards the end of the class, maybe last half an hour or 45 minutes, I'll be doing difficult questions. So it's up to you to, if you can't understand that part, maybe do some work and try to understand that part next week. If not, then again try to get answers for those questions by next week. If you can understand everything that I'm teaching, if you can understand every question that I'm doing, that means there's nothing new for you to learn from here. Me and you and this class is equal. Then it's a pointless class to join, right? So we'll be moving towards difficult questions towards the end of the class, and definitely there will be 1 or 2 questions that you can't understand. So that is the whole point of learning physics. You go home, then you try hard to understand them. So with time you would learn how to approach those questions. With time, then you will grow. So towards the end of the class, I'll be doing difficult questions, and after 2-3 weeks, we can start the mechanics revision tutes. In the mechanics revision tutes, there are like simple questions and extremely difficult Olympiad level questions too, because if you can easily understand something that I'm explaining, just don't waste time. You can use that revision tute too and try those questions, okay? I'm just trying to cater all the students with different capacities in the class. That's why I'm giving a lot of resources. So after 2 weeks, you will get the mechanics revision tute. So in the mechanics revision tute, there will be a lot of difficult questions. So if you are okay with the content that I'm teaching, just don't listen to the content. You can try those questions, okay? That's how the class goes. So I'm just trying to cater students with different capacities, and at the end of the day, after 5-6 months, if everyone improves, if everyone grows, then that is the whole point of this class. Okay, you can't find the page 12. Is that the case? I'll check that. Online students, I'm not talking about the PDF page number. I'm talking about the actual page number. Online students, I'm not talking about the PDF page number. I'm talking about the actual page number. You can go to that actual page number, check 12. After 12, again, page 1 starts. Again, page 1 starts after 12. my God, these letters are so artistic, it's difficult to read. Learn that you should. Yeah, it's same as maths. Yeah, in maths also you do the same thing. You have a underlined to represent that it's a vector. Yeah, it's the same thing. Yeah, and make sure that your letters are not too beautiful that it is difficult to read. Exercise 1. Exercise 1, question number 1, 2, 5, and 7, part 1. And for online students, like you can find the PDF, or else like you can contact the given number to deliver to get the tutes delivered. So use vector triangular law to get the answers. Today, I mean, won't be this session won't be that difficult. Okay, today we are just introducing vectors, so we have to go slow and steady until we understand all the notations and everything properly. Okay, the first one. You start by the first vector. You get the first vector. Then draw the first vector. Then it stops here. You get the first vector. Then draws that. Then it stops here. It stops here. From this endpoint, you start drawing the next vector. You draw B. Then from vector triangle, you get the resultant by completing the triangle from absolute starting point to absolute end point, right? So this is your resultant. This is your resultant. You draw a line from absolute starting point to absolute end point. You draw a line from absolute starting point to absolute end point. Then this is your resultant. This is A plus B. Clear? So this is A plus B vector. This is A plus B vector. Vector A plus B. This is vector A plus B. It's good to draw this line to mention that they are vectors. This is vector A plus B. Then the second one. You draw the first vector. You draw the first vector. Then this is the end point of the first vector. This is the end point of the first vector. From there, you start drawing the second vector. From there, you start drawing the second vector. Okay. Then it stops here. You first draw vector A. Then from the end point, you start drawing vector B. Then this is the absolute starting point. This is the absolute end point, right? Then the resultant will be from absolute starting point to absolute end point. So this is the size of vector A plus B. This is vector A plus B from here to here. It's quite practical, right? If you walk 5 meters, then move 2 meters back, the absolute distance that you travel is the difference, right? Clear? Clear? So it's practical, right? Whatever you get from the vector triangle law, it's practical. Clear? Clear? Next, let's move to question number 5. Let's move to the third one. Now what they need is F1 minus F2. So do I have a vector subtraction law? Sorry, vector subtraction law. I don't have a vector subtraction law. I only have vector triangular law. It's for vector addition, right? I have a law to add vectors, not to subtract vectors. Clear? So as a result, to get F1 minus F2, what I should do is, I should get minus F2. So what is minus F2? Same magnitude but opposite direction, right? So minus F2 is same magnitude but opposite direction. This is minus F2. Clear? Clear? Then I start by f1. So what I'm going to do here is f1 minus f2 I can write as f1 plus minus f2, right? f1 minus f2 I can write as f1 plus minus f2, right? Here. So now this is an addition. Here. Now this is an addition. So I first draw f1. f1 is 3 in this direction. I first draw f1. f1 is 3 in this direction. Then from where it stops, I draw minus f2. Minus f2. Clear? Because f1 plus minus f2. The magnitude is 4. Magnitude is 4. Then what is the absolute starting point? This is the absolute starting point. This is the absolute end point. Then I draw a line from absolute starting point to absolute end point. This gives me the resultant. Clear? So what is the resultant? I can use Pythagoras law to get this magnitude. It's 3 squared plus 4 squared square root. That means the value is 5. So the magnitude of this one is 5. Clear? So again using vector triangle. Clear? Try to get the answers in question number 7. All the answers for question number 7. So understand this carefully. You start drawing the second vector from the end point of the first vector, okay? Okay, you need the vectors Tute again, right? Well, vectors Tute in the Zoom chat again. Yeah, I'll provide the vectors Tute in the Zoom chat again. These are the questions from exercise 1, okay? These are the questions from exercise 1. Okay, you can't find that page. Okay, can you find exercise 1? The student who mentioned about the page 12 issue? Can you find exercise 1? Yes, right? So carefully check the Tute online students. I'm talking about the vectors and motion Tute. Daishika saha chalitaya. Vectors and motion Tute, okay? Vectors and motion Tute. Daishika saha chalitaya. Okay. Attention. Attention everyone, and be careful when you are drawing something. You start drawing the second vector where you stop the first vector, okay? That means actually you draw the triangle without lifting your hand. That's the idea, okay? You draw the first vector without lifting your hand, you draw the second vector. Then you get the resultant, okay? Just don't start the second vector from other points. You draw the first vector. Without lifting the hand, you draw the second vector. Then you get the resultant. Clear? Clear? Okay. Question 7. What is the change in velocity of the object as it moves from A to B? So from A to B, attention everyone. What is the change in velocity of the object as it moves from A to B? So, what is change? What is change? What is the change in velocity? Change means final value minus initial value, right? That's the convention, right? It's not physics, okay? It's not physics, that's the convention, right? Change means final value minus initial value. Clear? Clear? So here also, if they are asking the change from A to B, what you should do is get VB, then subtract VA. Is that clear? Change from A to B means, attention, change from A to B means VB minus VA, right? Always change means final value minus initial value. Clear? Final value minus initial value. So here change from A to B means VB minus VA, right? Clear? That's how we define change. Clear? So, what is VB? VB is V in this direction, magnitude V in this direction, minus VA is V in this direction. I don't know how to subtract vectors. So what I'm going to do is, I'm going to keep this V here, plus, then I'll give this minus mark to this one, this guy. Clear? Clear? I convert this to a plus and give minus to this one. So minus plus, I still get the same thing, right? Now, using the minus mark, I can shift the direction of this vector, right? Using the minus mark, I can shift the direction of this vector. Is that clear? Clear? Then, Then this is the first vector. From the endpoint, I start drawing the next vector. This is a vector triangle. Then this is the absolute starting point. This is the absolute end point. This gives me the resultant vector. This gives me the resultant vector. This is the resultant vector. So, if I use Pythagoras law, v squared plus v squared square root, that means 2v squared square root, that means root 2 into v. So the resultant is root 2 into v in this direction. Clear? Root 2 into v in this direction. Clear? Write this down. So last Saturday I wrote my last exam in the university, possibly the last exam in life. Thank you. But I mean, what I was going to tell is, what I was going to tell is, it's quite sad that you have to write, maybe 200, 300 more exams. Like you have more exams, right? Maybe if we properly calculate, for A-levels, maybe 100 more exams, different subjects, different exams, unit test, term test, A-levels, okay? Then, and let's try to avoid that, otherwise I can shy. Then, after that, university, maybe 10, if we account 10 exams per semester, then 8 semesters means 80 exams. Then after that, yeah. So if you are going to stop there, then that's the last set of exams. So yeah, altogether around 200 exams. So just try to enjoy exams. That's the only way out now. You have chosen the path, so that's the only way out now. Just start enjoying the exams. You have to be happy when I tell that next week you have exam. Okay. Let's move forward a bit. Attention everyone. Assume that you have 3 vectors, A, B, and maybe C. How are you going to add all 3 vectors? Only one way out for now. You draw the first vector. From the endpoint, you draw the, I'll just make it like this, otherwise it would be a bit difficult to understand. This is a bit lengthy. You draw the first vector, and the first vector stops here. Then from the endpoint you start drawing the second vector, B. You start drawing the second vector. Now you have to apply the vector triangle, so you get the resultant. So from absolute starting point to absolute endpoint, you get the resultant. So what is this? What is this? A plus B. A plus B. This is A plus B. Clear? Then you forget A and B. You have vector A plus B and vector C. So you draw vector A plus B. Then from the endpoint you draw vector C. Then you get A plus B plus C vector. Is that clear? So since you don't know how to work with more than two vectors, what you are going to do is you first start with two vectors. You get the addition of those two vectors, A plus B. Then with A plus B, you combine the third vector C. Then A plus B plus C, you get A plus B plus C vector. Clear? So you first use one triangle, then get the resultant, forget these two. Then you draw a triangle to this guy and this guy, then get the resultant. Is that clear? Is that clear? But now see, what is this? Actually that middle line wasn't required. If you draw the first vector, then the second vector, then the third vector, anyways you get the resultant, right? That middle line wasn't required. Clear? Although I used that to prove this thing, what actually happened was, you draw the first line, first vector, second vector, third vector, then you draw a line from absolute starting point to absolute endpoint, then this is the resultant. Clear? This is the resultant. Clear? A plus B plus C. Clear? So actually this vector triangle can be expanded up to a vector polygon now. See? This is a vector polygon, right? Some kind of a polygon. So if you have 100 more vectors, okay, maybe if you have 100 vectors, you draw the first vector without lifting the hand, draw the second one, third one, fourth one, fifth, 6, 7, 8, 9, 10, and you draw the line from absolute starting point to absolute end point. This is your resultant. This is your resultant. This is vector polygon law. Clear? So it's not only about triangles. You just keep drawing the vectors without lifting your hand. Okay? Then maybe you would get a polygon with 100 sides. Okay? Then you complete the diagram. That line which is required to complete the diagram is the resultant vector. Clear? Clear? Is the resultant vector. So you can directly use vector polygons for this. Is that clear? Clear? So you don't have to limit yourself to a triangle. You can draw vector polygons. Go to exercise 2 now. Go to exercise 2. So it's all about exercises, okay? In this lesson, we have to learn a lot of do a lot of exercises. Now we are doing simple exercises. Then there will be another book with difficult questions. Then we are going to finish those exercises. So it's all about doing a lot of questions in mechanics, okay? Move to exercise 2. I'll just show one question. Attention. Let's do the third one. Let's do the third one. Okay. Now you may have to, attention everyone, you may have to solve these kind of diagrams. What is the meaning of these diagrams in exercise 2? What is the meaning of these diagrams in exercise 2? The meaning is something like this. Have you seen some bridge? You take a bridge, they have these kind of structures, right? Maybe they have these kind of structures sometimes to balance its weight and all. Clear? They have these kind of structures. So what actually happens is there's a certain vector through this structure. There's a certain vector like this, certain vector like this. Then you should be able to solve when they give you a series of vectors or set of vectors like this. You should be able to find the resultant of these vectors. Clear? So same goes here. Exercise 2, question number 3. They have a diagram like this. A, B, C, D. Okay. A, B, C, D. Take this diagram, okay? Take this diagram. Now the meaning is there's a vector from A to B, vector from B to C, vector from C to D, vector from A to D. So what is the resultant vector here? What is the resultant vector? I'll just disconnect this line to make it easy to understand. So it's like this. You have vector AB, vector BC, vector CD, then vector AD. Now tell me, vector AB, vector BC, vector CD combined, what do you get? Attention. You get AD, right? Vector AB plus vector BC plus vector CD. What do you get? AD, right? Why? This is a polygon. Clear? You draw a vector from A to B, then you draw a vector from B to C, then you draw a vector from C to D. What is the resultant? Vector from A to D. So, as a result of these three vectors, you get AD. Then you originally have another AD vector, right? You originally have another AD vector. Is that clear? You originally have another AD vector. Clear? So the resultant in this system is 2 into AD. 2 into AD. Is that clear? So the resultant of this network of vectors is 2 into AD. Clear? You have A to B, B to C, and C to D, which gives you a vector AD. Then originally you had another AD vector. So all together you get 2 into AD. So this is the resultant vector of this system. Clear? So you should be able to analyze and get the resultant vectors like this. So start with exercise 2. Second one. Then fifth one. Then ninth one. Then ninth one. Try these questions. Quickly get the answers for question number 2, 5, and 9. Then if you get answers for these questions, just finish the whole exercise, okay? So if you easily understand these things, you can finish all the exercise, then you have nothing to do at home. Then I mean, it's quite easy, right? You just check the theory points and come to the class next week. So after maybe 2-3 weeks, you'll get the revision tute. Then you will have enough work to do, because there are some difficult questions which you have to maybe do a lot of calculations to understand. Should we write vector ABC in order? No. You don't have to think about the order. Do we have to underline the letter when you are right? Yes, I mean, it's not mandatory, okay? But it's better if you follow all the rules. So usually if you have this and this arrow, it already represents the vector. But it's good if you write something, just put the just underline that, okay? It's just good to follow all the rules. And do you have to follow the order? No, you should not. I mean, you don't have to follow an order. Why? See, vector A plus vector B, you get this. Instead of doing this, if you start with vector B, then vector A, you still get the same vector. See, these two are equal, right? Clear? So you don't have to follow an order. Clear? You don't have to follow an order when you are drawing triangles or vectors, okay? Triangles or polygons or anything, there's no order. Okay, you can change the order, you would still get the same answer. Then someone has asked me to explain this again. While you are trying these questions, I'll explain this again. This whole system AB, BC, CD, then AD. There are 4 vectors in the system. I take vector AB, BC and CD and draw a polygon for them. Vector AB, vector BC, vector CD. I take vector AB first, then vector BC second, then vector CD third. And I complete a polygon. Resultant of these vectors would be, to get the resultant, you have to draw a line from the absolute starting point to absolute end point. You have to draw a line from absolute starting point to absolute end point. So this is the resultant. This is the resultant. Absolute starting point to absolute end point, AD. This is the resultant. Then you only consider this one and this one. As a result, you have vector AD. But you originally have another vector, that is again AD. So if you add this vector and this vector, AD and AD, you get 2 into AD vector, twice the size of AD vector. Is that clear now? For the student who asked the question, is that clear? Cool. So you're getting your results within 2-3 weeks, right? I mean, I'm telling this for like 5-6 weeks now, but I mean, you're not going to get results, right? They always mention that you're going to get results within 2 weeks, right? Now it's actually 2 weeks, right? Cool. So then will your school start, so what's going to happen? Now I can remember what happens after O-level. Your school start immediately, or is there a period of time where students apply for other schools kind of stuff? I can't remember. And don't change your school just for the prestige, okay? Because I mean, Now there are, I can't tell the names, okay? Now I can't mention the names actually, but there are a set of schools which are not the most popular schools are who performs really good in A levels now. There are a set of schools. I mean, there are popular schools also, but there's a set of schools which performs really well in A levels now. So check with your school seniors maybe. Okay, check with the seniors of your school. Can't mention the names here, so if you like, you can personally come and meet me. I'll mention. Okay, can't tell these kind of stuff in public. So there's a set of schools which performs really well in A levels. So maybe ask from your seniors also, like what happens in your A level classes. How's it going? Do they finish the syllabus on time? Then check with the seniors of the school that you are going to maybe you are planning to go. Check everything before changing your school, okay? Yeah, some of you are already going to school. Yes, I know that. Okay. To make things easy, attention everyone. To make things easy, I'll first do the second question. In the second one, the answer is 0, right? Attention. In the second question, the answer is 0, right? Why? You have vector AB. In the second question, you have vector AB, then BC, then CD, then DA. AB, BC, CD, DA. This is a complete polygon, right? I mean, you take vectors one by one. You take vector AB. Without lifting your hand, you draw vector BC. Without lifting your hand, you get vector CD. Without lifting your hand, you draw vector DA. Okay? You draw vector DA. Then after everything, attention everyone, after everything, you are trying to get the resultant, right? After everything, you are trying to get the resultant. For that, you have to draw a line from absolute starting point to absolute end point. What is your absolute starting point? This. What is your absolute end point? Same. So you can't draw a line from absolute starting point to absolute end point, right? There's no line from absolute starting point to absolute end point, which means your resultant is 0. Clear? Which means your resultant is 0. So, if your vector diagram is complete, if your vector diagram returns to the starting point, if your vector diagram returns to the starting point, that means the resultant is 0. Clear? The resultant is 0. And it's practical, right? You move in that direction, that direction, that direction, and if you return to the same point, the resultant is actually 0, right? Clear? So if your vector diagram completes, then the resultant is 0. Attention, attention, but properly understand the difference between these two diagrams, okay? Here, it goes like this, and this. Here, it goes like this, but this is in this direction. See? It's a different scenario. Clear? In this diagram, this vector goes in this direction, this direction, this direction, and the fourth vector is not in this direction, it's in this direction. So it's not going to complete your vector diagram. But here you start here, draw this one, then this one, this one, this one. See? You can complete a vector diagram here. Clear? Which makes the resultant 0. Clear? Which makes the resultant 0. Now try other questions. Just let me know if you need me to explain this again. But anyways, if your vector diagram returns to the starting point, the resultant is 0. Clear? If your vector diagram returns to the starting point, then your resultant is 0. Try 5, 9, then maybe 11. Okay, there's a question like, does this work, this scenario works only for polygons? Does that work for vectors? Yes, it works for work for triangles also. How? I mean, for a vector triangle, vector AB, first vector, then vector CD, second vector. It returns to the same point. So the resultant is 0, right? Clear? Clear? So for a triangle also, if it returns to the starting point, resultant is 0, right? You walk 5 meters, you return 5 meters, then you are at the starting point, right? Resultant is 0. Clear? Clear? So if your vector diagram completes, if it returns to the starting point again, then the resultant is going to be 0. Clear? If your vector diagram returns to the starting point, resultant is going to be 0. Question 5. Okay, attention everyone. Attention, stop talking. Everyone. Okay. You can have your discussions, but I mean, just minimize your sound, okay? Because I mean, some students are listening, that's why. So, I'll break this into 3 parts. I'll break this into 3 parts. One, these 3 vectors, then this vector, then this vector. I'll break the system into 3 parts. Clear? I'll break the system into 3 parts. Clear? Then, this is A, D. Now tell me, what is the resultant of these 3 vectors? Attention, attention. What is the resultant of these 3 vectors? You start from here to here, then here, then here. Resultant is AD, right? Resultant is from point A to point D. Clear? Then you get these 2 vectors. You start here, draw this one, then this one. You draw a line from absolute starting point to absolute end point. Again AD, right? It's another vector from A to D. Clear? So now in your system, you have AD, AD, and naturally there was AD. Initially, can you remember? Initially there was a line AD, right? A vector AD. Clear? So as a result of these 3 vectors, you get vector AD. As a result of these 2 vectors, you get vector AD. And originally you had vector AD. So you get a resultant of 3 into AD. You get a resultant of 3 into AD. Clear? Resultant is 3 AD. Next, let's move to question number 9. Okay. Here you have a lot of zeros, right? Why? Attention. Take this polygon. You start here. Attention everyone. You draw this vector, then this vector, then this vector, this one, then this one, from here to here, then this vector, and this one. See? These vectors returns to the starting point. So you take those vectors and remove them from the system. Why? Resultant of those vectors is 0. Clear? Resultant of those vectors is 0. Clear? Because they returns to the same point. Then you draw this vector. Attention everyone. Then this vector, this one, and this one. See? These 4 vectors combined, they returns to the same point again. Clear? They returns to the same point again. Clear? So all you have is this vector, right? All other vectors cancels out. So you have remaining AE, vector AE. Clear? These vectors cancels out, these vectors cancels out, then the resultant is vector AE. So why do we need to add the same vector as 3AD and all? The reason is you have the same vector repeated here. That is the issue. You have the same vector repeated here. There's a vector going from here to here as a result of these 3 vectors. There's a vector going from here to here as a result of these 2 vectors. And originally there was a vector like this. So when you are combining things, you have vector AD 3 times. That means altogether you have a vector 3 into AD. Clear? Is that clear? The student who asked the question? Okay. Attention everyone. Attention. Stop talking. Attention. Okay. So this one, be careful when you are doing this question, okay? Be careful when you are doing this question. Why? This is not 0, okay? This is not 0. Why? You can't use the same vector twice to make everything 0. That means you can tell, see, this vector completes everything. Then it is 0. Then again this one, and this one, it's a complete diagram, then it is 0. But this is not 0, okay? Why? When you use this vector once, you can't use that again. That means you start from this point, use this vector, then this vector, this one, and returns here. They become 0 because they complete a polygon, right? They returns to the same point. Clear? They returns to the same point. But now you have these 2 vectors remaining. Now you have these 2 vectors remaining. What would be the resultant? This is the absolute starting point, this is the absolute end point. Then you draw a line, this is the resultant. This is the resultant. That means vector AF. Vector AF. Clear? Vector AF. Clear, everyone? These vectors complete each other. Then you have these two vectors remaining. You draw this vector, then this vector, then the resultant would be this vector. Clear? Is that clear? Attention. I mean, just think practically. What happens if you start walking from this point, then you go from here to here in this path, then you go in this path, where you are going to end? Here, right? So actually you went from here to here. So practically it's, the same thing, right? If you start walking from here, you walk in this path, then return to the same point, then go in this path, then this path. So actually you started here, you stops here. So the resultant is from A to F. Clear? The resultant is from A to F. Clear? So it's the practical answer, right? So the vector polygon gives us the actual practical thing that's going to happen. Clear? Okay, it's quite important. Okay, in physics we always have to check that. Even for 25 batch students, when they are doing questions, one thing that I always ask is, when you are doing calculations, check whether these are practical answers. Okay? Check whether these are practical answers. If you do a calculation for a person, if the speed of that person is 30 meters per second, then it's too much, right? Then check your calculations again. In A-levels, they usually give you practical answers. In A-levels, it's not a rule, but it's an ethic. You always get practical answers. You always get practical answers. So you won't get very different answers from practical answers. Clear? So one thing I always ask from 25 batch students, whenever you are doing a calculation and get the final answers in papers, check whether that's practical. If it is not practical, just check your calculations again. Okay? So what would be the maximum velocity that a person can move usually? 10 meters per second? Yes, possible, right? 10.1 or something like that? Maybe 10 meters per second is a huge value, but we discussed this earlier, right? 10 meters per second is a huge value. See, in 1 second you move 10 meters. But 100 meter record is 9 point something, right? 100 meters record is, 100 meters Olympic record is 9 point something. So 100 divided by 9 point something, you get 10 point something, right? So people are capable of running 10 meters per second. Clear? People are capable of running 10 meters per second, but not more than that. Yes, you can use triangles also if you like. There's a question, answer is 2AF. No, it's only AF. Now is that clear after the explanation? The student who asked online. Okay. Okay, there are a few questions. How to know the endpoint of a polygon in this case? You don't have to specifically think about that. Whatever you do, you would get the same answer. Whatever you do, you would get the same answer. Okay? I just break this in a way that it's easy to understand for me. Otherwise, you can break it in a different way and try to get different answers, but still you will end up with the same answer. But this is the only way that it's possible without using other equations. If you break this in a different manner, you may have to use vector parallelogram kind of stuff, things we are going to learn next. So this is the only possible way for me to understand this easily, right? That's why I break it into 3 parts like this. But you would still get the same answer. I mean, attention everyone, attention. Uh, this is not a very good explanation because I can't draw the perfect diagram, but still you should understand this. You draw vector AB, just think like this. I mean, you forget this diagram. You forget this diagram. Attention everyone. You forget this diagram and take vector, one vector by vector. You draw AB, then BC, then CD. Then you pick any vector you like, maybe AE. Maybe AE. Then ED. Then vector AD. This is the resultant diagram. What are you going to get? You are going to get a vector from here to here. It's like 3 into AD, right? Thrice the length of AD. This is AD. This has the length of AD. Then again this has the length of AD. See? I mean, I'm just making things easy by breaking it like this. Otherwise, you take vector by vector and complete a polygon, you still gonna get thrice the length of AD. I mean, here it's not a perfect diagram. If you measure everything and draw the perfect diagram, okay, you just don't think about how to break this thing or anything like that. You just use the vector polygon law directly. You take vector AB, then draw the next one, this one, then from where it ends, draw this one, from where it ends, draw this one. Like that, you just keep drawing the vectors continuously without lifting your hand. Clear? You just keep drawing the vectors without lifting your hand. That means you put all the vectors into one polygon. Still you are going to get thrice the length of AD. That's what we mean by 3AD. See? That's the meaning of 3AD. Clear? Clear? So here what we are doing is, to make things easy, I consider these things as small polygons, which makes my life easy. Otherwise, I can draw one big polygon. Still, you are going to get the same answer. Clear? Clear? So you don't have to think actually where to start, where to end. Anyways, you are going to get the same answer. Clear? I think I gave the answer for this one also. So this is the answer for all the questions that you have asked, okay? You can choose whatever the vectors you like in whatever the order. Still, you are going to get the same answer. Clear? Clear? So 3AD means thrice the length of AD. Clear? 3AD means thrice the length of AD, like this. Clear? Is that clear, everyone? Clear? For question 9 also, you have asked the same question. The answer is same, okay? Think, you draw a polygon like this. You draw like this, then this, 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 this. Then without lifting your hand, you draw this vector, this one, and this one. Then without lifting your hand, you draw the remaining vector. At the end of the day, this is the absolute starting point, this is the absolute end point, right? This is the absolute starting point, this is the absolute end point. So the resultant is AE. See? Resultant is AE. Clear? You just draw a line from absolute start point to absolute end point. Clear, everyone? Clear? Question? Okay, attention everyone. Uh, it's not your interval time, right? No, right? Let's finish this theory point and give you the interval. Uh, I mean, it's not that difficult to stay in this class, right? You anyways don't listen. So, okay, attention. So, this is the story. Now we worked with vectors, but all we did was drawing diagrams, right? Drawing diagrams. So drawing diagrams is not that healthy. Why? Assume you have 100 vectors, 1000 vectors. It's impossible to draw diagrams, right? So it's essential to build equations if possible. Build equations if possible. So, and again, like now, even these days, we had some modules like radar, all these things, do vector resolution, vector addition, vector division. So, for these stuff, okay, if you keep drawing vector polygons and triangles, it's not going to stop, right? So, even for our syllabus, at least for two vectors, it's good if we can create some equations, right? Without always drawing diagrams, okay? Without always drawing diagrams, it's good if we can maybe create equations to get the resultants. Clear? So how are we going to create equations? For that, I mean before that, we should learn vector parallelogram law. Vector parallelogram is nothing new again, okay? It's the same thing. Vector parallelogram means assume you have a vector like this and another vector like this. To get the addition of these two vectors, what you can do is you put this into two sides of a parallelogram. That means you draw vector A, then you draw vector B starting from the same point, okay? Not like in a triangle, not like in a vector triangle. From the same point, you start vector A and vector B. Clear? From the same point, you start vector A and vector B. Then you complete this into a parallelogram. Clear? Then you complete the diagram into a parallelogram like this. Clear? Then you complete this into a parallelogram like this. Clear? Then this diagonal will give you the addition of A and B vectors. Clear? This diagonal will give you the addition of A and B vectors. And what you should understand is, this is actually the vector triangle, right? Why? In a parallelogram, if this is B, this side has the same magnitude and same direction, right? This side also have the same magnitude and same direction. Clear? Clear? So if this is B, this is B, this is B. So you start here, draw vector A, then draw vector B, draw a line from absolute starting point to absolute end point. You get A plus B. This is actually a vector triangle, right? So parallelogram law is not a new thing, okay? It's just vector triangle represented in a different way. That's all. Clear? Is that clear, everyone? It's the same law, okay? Nothing new, okay? It's the same law, nothing new here. Clear? So the rule is you put two vectors into two sides of a parallelogram, then the diagonal gives you the resultant. Clear? Clear? Clear, everyone? Okay. Now, Let's create an equation. You have vector A, vector B, that means magnitude of this vector is A, magnitude of this vector is B, and angle between them is theta. You should be able to, attention, you should be able to get the resultant, okay? You should be able to get the resultant without drawing a diagram, okay? Without drawing any diagram. If you have this data, you should be able to get the resultant. What is the data set? Magnitude of A, the magnitude of this vector, and angle between them. You should be able to get the resultant. Clear? So to create an equation, let's draw a parallelogram again. Okay. This is vector A. This is vector B. Since this is a parallelogram, if this is B, this is B. If this is A, this is A. This is the resultant. For now, I'll take it as R. Attention. For now, I'll take that as R. Clear? I'll take this as R. Okay. Now, let's complete this diagram like this. And the angle between these vectors is theta. Angle between these vectors is theta. So I'll draw this diagram like this. If this is theta, this must be theta, right? If this is theta, this must be theta. Clear? Then I'll take this as x, this as y. I can take this as x, this as y. Clear? You can understand that, right? If this is theta, this must be theta, right? You had that kind of a law in all levels, right? Okay. So I can write sine theta equals y over b, cos theta equals x over b. Cos theta equals x over b. Clear? Cos theta equals x over b. Sin theta equals y over b. Cos theta equals x over b. Then y equals b sin theta, x equals b cos theta. Then what is this full length? What is this full length? It's a plus x. That means a plus b cos theta. A plus b cos theta. Clear? This is a plus x. X means b cos theta. Clear? Then what is this? It's y. Y means b sin theta. So, I can apply Pythagoras law to find r, right? How? R squared equals, this is a plus b cos theta, this is a plus b cos theta squared plus this is b sin theta squared. So r squared equals a plus b cos theta squared plus b sin theta squared. Clear? Clear? So I get r squared equals a squared 2ab cos theta plus b cos theta squared again plus b sin theta squared, right? A squared 2ab cos theta plus b cos theta squared plus b sin theta squared. Clear? So I can get r squared equals a squared plus 2ab cos theta. This I can write as b squared cos squared theta. You know that this is how we write cos theta squared, right? This is how we write cos theta squared. Square root of cos theta we write as cos squared theta. Clear? Cos theta squared means cos squared theta plus b squared sin squared theta. So a squared plus 2ab cos theta plus, I have b squared in common, sin squared theta plus cos squared theta. A squared 2ab cos theta, I take b squared out, sin squared theta plus cos squared theta. What is sin squared theta plus cos squared theta? Sin squared theta plus cos squared theta is 1, right? Sin squared theta plus cos squared theta is 1. Then you get a squared, then here b squared plus 2ab cos theta equals r squared, then r equals square root a squared plus b squared plus 2ab cos theta. 2ab cos theta. Clear? A squared plus b squared plus 2ab cos theta. Now with this equation, if you know a, b and theta, without doing anything, without drawing any diagram, you can find the magnitude of the resultant, right? You can find the magnitude of the resultant. Clear? Clear? But there's a small problem. This resultant is a vector. Knowing the magnitude of a vector is not enough. Clear? knowing the magnitude of a vector is not enough. Clear? So you can't stop at the magnitude. You definitely have to find the direction. So to find the direction, I'll maybe use an angle like alpha. So if I find alpha, then it's okay, right? Because I know the direction of A. If I can find the angle between A and R, if I can find the angle between A and R, then I know the direction of R, right? Clear? So I can easily find tan alpha, right? I can easily find tan alpha. Tan alpha will be B sin theta, B sin theta over A plus B cos theta. A plus B cos theta. Tan alpha equals this one over this one, right? This is a triangle. Tan alpha means this one divided by this one. Clear? That means B sin theta over A plus B cos theta. Clear? So I can write alpha equals tan inverse B sin theta over A plus B cos theta. So you can do the calculations and find the tan value from the log table, right? Clear? Okay. If you know this value, to get alpha, you can use inverse tan. Clear? This is just a symbol for inverse tan. Okay. This is just a symbol for inverse tan inverse. Clear? Okay. Okay. So I'll give you the interval now. You can try these questions after the interval. So the time is around I'll start around 5:37, 20 minutes interval. Okay, 5:37. Be here on time and start doing these questions. Exercise 3, question number 1, part 2, part 4. Exercise 3, question number 4, 5 and 6. And just let me know if you have any questions after the interval. If required, I'll explain this again. There are some online questions. I'll respond to them too after the interval. Try the question numbers given, okay? Try these question numbers. Exercise 3, 1, 2 and 4. Then question number 4, 5 and 6. Okay. Like, there are some questions. Until you are trying these question numbers, I'll explain those. There are some questions. I'll answer them until you answer these questions. So quickly go through these questions. Exercise 3, question number 1, 4, 5 and 6. One question is whether A plus B equals B plus A. Yes, definitely. Why? Order doesn't matter, right? Order doesn't matter, so definitely A plus B equals B plus A. So that's the answer. And so could you explain how you got sine square theta plus cos square theta equals 1? So, and also what do you mean by if we found the angle between A and R? We can find the direction. Could you explain? Okay. Another question. How, attention everyone, how sine square theta plus cos square theta is 1. I explained this in the first day of the class, as I remember. This is just something related to maths, and like if you need to follow some more mathematics, there's, I think I haven't uploaded the last 2 recordings. I'll upload them today. There are some sessions going for bio students, some math sessions going for bio students through the website, Maths for Bio students. So you can watch those recordings. Attention everyone, please be silent. Okay, if you need more mathematics, there are some sessions going on for bio students in the website, our website, to teach some maths parts for bio students. You can get them from our website. That means anyways from next week onwards, usually the class happens through the website. So you can check the WhatsApp group and get all the details related to the website and get the access to the class from the website. And if you need any assistance for that, or if you need to join the group or anything like that, you can contact this number. You can contact this number for that. 070-154-6825. you can contact this number and get the website details, Maths for Bio students, links and all, if you need anything. Okay. Anyways, when you are joining online for physical class students and online class students, they can get the access by uploading the slip. Then you can find the Maths for Bio students online sessions. Otherwise, this is a mathematical identity. Sin square theta plus cos square theta is always 1. Clear? I can easily explain that if you want. How? This is theta, this is A, this is B, this is C. Sin square theta means, sin theta means A over C. So it's A squared over C squared. Cos square theta means, cos square theta means, cos theta means B over C. So cos square theta means B squared over C squared. Then sin square theta plus cos square theta means A squared over C squared plus B squared over C squared equals C squared. Here A squared plus B squared. According to Pythagoras law, A squared plus B squared equals C squared. So you get C squared over C squared cancels out equals 1. That's how you get sin squared theta plus cos squared theta equals 1. Hope you got the answer for that question. Question number 14, it's marked correct because it's an all. Okay, question number 14 in today's paper, it's marked correct because it's given correct for everyone. And for the first question number 1, please correct your answers. It should be momentum. Answer for the first one is momentum. These issues won't happen from next week onwards because we are starting the paper discussion anyways. So it would be momentum. First, for the first one, answer is momentum. And again, everyone, so just let me know, if we start the class at maybe 3, 4. Okay. Who finds it difficult to stay in the class if it goes until 8:30 with the paper discussion? So in the middle, you always have the option of leaving the class. So, I mean, so the plan I'm working on is maybe like anyways your schools are starting. So if we can write the paper from 3 to 4, everyone can write the paper. Then 4 to 7:30 main class, we can get 10 minutes from this and maybe end around 7:20. Then start around maybe 7:40 to go until 8:30 with the paper discussion. So is this plan okay? Okay, 3 to 4, 4, 5, 6, 7, 7:30, okay, 7:40. Yeah, right? Yeah. So anyone who finds this difficult? Anyone? I mean, difficult in the sense, if it is difficult to you, for you to, I mean, wear that, it's not my problem. Other than that, transport issues or issues like that, okay? Any issues like that, just let me know. So the class plan, can we shift to this plan? Is everyone okay with this plan? Because anyways, within 2-3 weeks, schools are starting. So it's good to shift the plans now, right? So everyone okay with this plan? Attention. Then from next week onwards, paper from 3 to 4, but 3 to 4 means actually 2:45 to 3:45. Attention. Weekly paper 3:45 to 4:45. Sorry, 2:45 to 3:45. Then the class 4 to 7:30. Okay. Then the paper discussion maybe 7:40 to 8:30. So this one is not mandatory. If you like, you can write the paper, or else you can get the paper and write it within the week or do something like that. Okay. Again, this one is not mandatory. Okay. Because you can like leave the class at 7:30, go home. I'll anyways provide the recording in the website. Later, in your leisure time, you can watch this discussion. Okay. This is mandatory. Otherwise, no point of coming to the class. Okay. This part is mandatory. Okay. So can we shift to this plan? Okay, everyone. Because anyways, you will get your results soon. Then I think some schools have started now. So a lot of students are missing the paper. Okay, so we can go with this plan. Attention. Some students, due to different issues, may find it difficult to write this paper, but will be able to stay from this time to this time. For them, I have the possibility of giving the paper maybe one day before you. I mean, I won't be able to read your marks or anything like that. But you can try the paper at home and come to the class. Then you can stay from this time to this time. You have that option. So we write the paper, we mark that during the discussion, during the theory class. Then I do the paper discussion directly. Clear? Clear? So you always have the option to leave at 7:30. Then you always have the option to leave at 7:30. Then watch this recording later. Clear? Clear? I'll like align everything in the website properly so that you can easily find the paper, the discussion, everything. Okay? So missing a paper or a discussion won't be an issue. This one you definitely should join. Okay? Clear, everyone? Because from next week onwards, we are starting mechanics questions in your papers. There will be structured questions. There will be essay questions. So there are stuff to discuss. At least the most difficult questions we can discuss every day. Okay. Yeah. Attention everyone. And if possible, I mean 1:30, 2:30, I'm not sure whether it's possible for you to be here by 2:30. Is that possible when your school starts? Everyone? Yeah, for you guys, definitely. I mean, there are schools far away, right? No, right? It's difficult to be here by 2. It's easy. No, right? You can be here? Not, I mean, school ends at 1:30. You would leave the school at maybe 1:45. So it's difficult to be here by 2:30, right? Yeah, yeah. So let's keep the plan to 3. 2:45, try. Anyways, if you miss the 2:45 session, you can start the paper 3 at 3. You will only miss the interval between 4 and the class, okay? So you can, if it's difficult. Yeah, from next week onwards. From next week onwards. There is no point of like keeping this plan because anyway schools will start soon. So the plan is from next week onwards, okay? Clear everyone? The plan is from next week onwards. I know anyways few of you guys will forget this and come to the class. We'll make our invigilators and papers available for them. Anyways, okay? Anyways, like 50% of the class will forget this and come to the usual class plan. That usually happens. Yeah. Is that clear, everyone? Normal class plan from next week. And attention, just don't think that we are starting things too soon. Why do we need a paper now? You would understand everything with time, okay? When everyone's struggling at the first term test, you would find it easy. That's my main target, okay? Because from the first term test, if you can perform very well, best thing is, if you are performing very well, nobody cares about your attendance, okay? So if you perform very well, I mean, even teachers are not worried about you. So you don't have to go through the trouble of like, I mean, getting too much attention from teachers. Again, you're in trouble, right? Why aren't, I mean, anyways, their job is to make sure that you are getting good results. That's why they are really worried about you. I always tell these school teachers. So you won't be able to do a sport. You won't be able to join societies. You won't be able to maybe take at least one day holiday from school if you are not getting good marks. But if you have good marks, they can stop worrying about you. Then you would be able to do whatever the sport you like. You would be able to do whatever the thing you like, okay? Same story when, I mean, it was the same story for me. I was the school captain for table tennis and I did 2 more sports, okay? In the first term test, I said you in the first term test, within 2 months, our section head asked me to stop doing science and go to the art section, okay? Because I mean, anyways, I'm not participating in the class, I don't have attendance, anything. But in the first term, I was the section first, from a like 20-30 marks of lead. So after that point onwards, I just give a call to my class teacher and tell, sir, mark attendance tomorrow, I'm not going to come. I have a tournament. I know that's not the case today. It's a little bit different than that. I mean, I'm talking about 19 levels, okay, not 100 years ago. But anyways, so after that point, teachers stop worrying about you. Anyways, when you are the section first, they don't have to worry about you. So I mean, after that, I can do whatever the sport I like. I was able to do whatever I was able to join whatever the society I like. I had practices sometimes for in the whole tournament season. Nobody thought about that, okay? Nobody cares. Why? If I'm getting the result, then they don't have to be worried about me. No one, not even the sectional head or anyone, because I always promised them that anyways I would get a good result. So getting good results in the first term test make your life really easy, okay? So it is one of the main targets for everyone in my class, okay? Getting very good results in the first term test makes your life really easy, okay? So everyone focus on that. That's why we are starting papers soon. Getting good marks in the second term test won't do this, okay? Then attention is deviated. First impression matters, okay? First impression matters. So getting good marks in the second term test doesn't have the same kind of effect, okay? First term test, okay. Everyone like thinks, okay, he get good result, anyways we don't have to think about him. Or anyways we don't have to think about her. Then it's over, so you can do whatever you like. So it's a nice plan, so yes, we have to focus on very good results on the first term tests. That's why I'm doing papers, paper discussions, everything. Okay. Okay, it's a good observation. Next week is a poet day. Can we do classes on poet days? Is it? I mean, anyways, you are not going to do anything useful on that day, right? Really, you need a holiday on poet day? Really? I was just explaining the plan for next week. Okay, I'll think about that. Towards the end of the class, I'll let you know. Okay, there were some requests to explain this equation again, but first of all, I'll do some questions, then return to the explanation again. Because with some questions, you would understand that, attention, attention, proof of this equation doesn't matter if you can actually use these equations directly, okay? Proof doesn't matter if you can directly use the equation properly. But anyways, I'll explain the proof again. But first I'll do one or two questions. So are you sure that next week is a poet day? Mali, Nora, check whether next week is a poet day. Yeah. Which poet is that? Asala. What are the significant stuff happened in Asala poet? So you don't know, right? So that means you don't actually need, I mean, there's nothing to celebrate then, right? Okay. Attention, everyone. Attention. Someone's asking my age. I'm 2000 born, so year is my birthday. Year is my. So 24 means 24, 25 means 25, 26 means 26. It goes like this. Okay. Attention, everyone. It's just using the equation. Okay? Attention. Stop talking. It's just using the equation, okay? Resultant is p squared plus q squared plus 2pq cos theta. Initially it was a and b, now p and q. So I put 3 at the place of p. Instead of q, I put 5. Then theta is 30. That's all. Clear? You directly get the answer. Then to find tan alpha, you get q sin theta. So Q means 5. Sine theta means 30. P means again, P means 3 plus, again Q means 5 cos 30. Now you can solve this, clear? Now you can solve this. I may need the calculator to solve this. Mali, calculate. Okay. You can't use the calculator. I mean, I can't use the logbook here. Okay. And I even don't know how to use the logbook now. Okay, attention everyone. Attention. I mean, you know how to solve this, right? You just use the calculator. Sorry, use the logbook, that's all, okay? I mean, cos 30 you know, sin 30 you know, cos 30 you know. If you don't know, you can again use the logbook to find sin 30, cos 30 and all. So just learn how to do the calculations, okay? I'm not going to explain those stuff here. And attention, someone asked me, how can I know the direction if I know alpha? Why? I mean, if you have P like this and Q like this, and if the resultant is like this, if its magnitude is 7.74, and the angle between P and the resultant is this, now you actually know, right? Now you actually know the direction of resultant, right? Why? Originally we know the direction of P. Originally we know the direction of Q. So when I find the angle between P and the resultant, I know the direction of the resultant. Why? If I know P, if I know the angle between R and P, I know the direction of R, right? Clear? Many students ask the same question. How can I find the direction of R just by knowing the value of alpha? Alpha is the angle from a non-vector. Clear? Alpha is the angle from a non-vector. Clear? So non-vector means you know the direction. So when you know the angle, you know the direction of the other vector. Clear? So if you can find alpha and if you can find R, you know everything about the resultant vector. You don't have to draw anything. Clear? That is the whole point of using these equations. And even if you don't understand how to derive the equation, I usually derive all the equations. But even if you don't understand how to derive the equation, if you can directly use these two equations, then you are good to go. Clear? Clear? Okay. I looks like 19. Look. Okay. They're asking for my birthday. Okay, සිල් ගන්න තියනවලු ඒ පාර. Okay, there's someone giving relationship advice too. Okay, cool. Next one. Question 4. Or else, there's another plan if you like. But we can mark the paper that way, right? Anyways, just, so anyone having that issue with that, okay, next week I'll give a holiday then, okay? Then the week after that, just let me know anyone having issues with doing the class till 7:30. Let's forget about 7:30, 8:30 paper discussion. You can leave the class and watch the recording later. Staying up to 7:30. And if anyone is having issues, anyone? Please let me know, okay? At least after the class, let me know, okay? At least after the class, let me know, because otherwise, I can try something like maybe start the class at 3 and do until 6:30, then give the paper later or something like that at least. Okay, would be difficult, very difficult to mark the paper, but I can try something like that, okay? I can still try something like that. So let me know if you are having issues with doing the class until 7:30, okay? Just let me know, okay? Because I can't think about any other plan. That's why. Yeah, so next week holiday, week after that, that plan will continue. So theory class would happen until 7:30, 4 to 7:30, 4 to 7:30, paper 3 to 4, then 4 to 7:30 you have the theory class, 7:30, 8:30 paper discussion. But just let me know if you are having issues. I can change the plan a bit. Please wait and inform me at least after the class, okay? At least after the class, inform me, okay? I'll try to do something. I saw some concerns with online students too. Yeah, I'll try to resolve, but just let me know, okay? Inform me whatever the issues you have. Okay, so here also using the same equation. R equals P squared plus Q squared plus 2PQ cos theta. Then P is 50. I can get the square of both sides. R squared equals P squared plus Q squared plus 2PQ cos theta. So how to find theta? Cos theta equals R squared minus P squared minus Q squared over 2PQ. Attention everyone. I just keep cos theta here. Attention. Stop talking. I keep cos theta here. R squared minus P squared minus Q squared divided by 2PQ. So R is 130 squared. P is 50 squared, Q is 120 squared, 2, 2, P means 50, Q means 120. It's going to be 0. 120 squared minus 50 squared, 50 squared, 130 squared. Isn't it going to be 0? Minus 120 squared. Yeah, it's 0, right? 130, other papers. Yeah. 130 squared minus 50 squared minus 120 squared is 0, right? Thank you. Sorry? Okay. Is that clear? It's going to be 0, right? Clear? I mean 50, 120 and 130 is a Pythagoras triangle. Okay? You have to know these kind of stuff if you finished O-level successfully. So 13, 12, 5 and 13 is a Pythagoras triangle, right? So 130 squared minus 50 squared minus 120 squared is 0, right? Clear? So the answer is 0. Clear? So cos theta 0, what is theta? Cos theta 0, what is theta? Theta equals 90, right? Cos 90 is 0. Cos 90 is 0. Clear? Cos 90 is 0. Is that clear? Everyone? So in this case, theta is 90 degrees. Clear? Theta is 90 degrees. Then how to find alpha? Tan alpha means Q sin theta over P plus Q cos theta. Attention. Q sin theta over P plus Q cos theta. Equation for alpha. Clear? So, what is Q? Q is 120. Sin 90. Theta is 90 now. P is 50. Plus Q is 120. Then cos 90. Cos 90 is 0. Attention everyone, stop talking. Cos 90 is 0. Clear? Cos 90 is 0. Sin 90 is 1, right? You have to remember these things now. Sin 90 is 1. Stop talking everyone. Sin 90 is 1. So I get 120 over 50. That means 12 over 5 as tan alpha. You can use the logbook to find tan alpha. Alpha. 12 over 5 means 67.38. 67.38 degrees. So the resultant would look like, you have P like this. P is 120. Then you have 90 degrees angle. Then you have Q here. Q is 120. P is 50. P is 50. P is 50. So the resultant is, they have given 130. Resultant 130. Angle between P and the resultant is 67.38 degrees. Clear? 67.38 degrees. Clear? Clear? Everyone? Write this down. I may need like 5-6 minutes additionally today, okay? I have to discuss one more question. Yes, you are true, okay? Sorry for that. You are true. Using the logbook, you won't get this answer. You would get 67 degrees and some amount of this. In the calculator, what I get is point decrease. Point decrease. Clear? Yeah, I can divide it by 100 and multiply by 60, right? Yeah, I don't know how to change that option. Yeah, clear? Using the calculator, I get point something degrees, but when you use the logbook, you get an answer like this, right? Clear? Okay. Quickly write this. I have to discuss one more question so that you can get a small idea about how to approach these questions. Then I can discuss all the difficult questions in exercise 3, not next week, the week after that. So attention everyone, it's all about identify what is P, what is Q, what is theta, what is R, and applying for the equation, okay? That's all. Nothing complex here. So even if you don't understand how I get the equation, you can still use the equation properly, okay? Just identify the proper terms and apply for the equation. Okay, attention everyone. I'll explain this question again, but I need to show you how to approach these questions so that you can try the questions in exercise 3. These exercise 3 questions are difficult, okay? These exercise 3 questions are difficult, but I need you to try these questions. So I'll quickly go through one question. But if you don't get the answers for exercise 3, it's all okay because it has on a set of difficult questions actually. If I quickly go through with question number 4, attention everyone. They are telling there are two vectors, magnitude root 3f, 2f is perpendicular to root 3f. Resultant of two vectors of magnitude root 3f and 2f is perpendicular to root 3f. Find its magnitude and angle between two vectors. Attention, the best option always is not to use the equation, okay? Sometimes using a parallelogram would help you. Okay, for an example, I will do this question using a parallelogram. If the resultant of two vectors of magnitude root 3f and 2f, I have a vector root 3f and the other vector is 2f. Listen properly. The other vector is 2f, but the resultant is perpendicular to root 3f. So how would the parallelogram looks? What should be the pattern of the parallelogram here? If the resultant looks like this, so they are telling that the resultant is perpendicular to root 3f. They are telling that the resultant is perpendicular to root 3f. Then the parallelogram should look like this, right? This is the other force, 2f. Clear? You have root 3f and 2f. Resultant is perpendicular. Resultant is perpendicular to root 3f, right? This is how the parallelogram looks like here in this question. Clear? So sometimes it's easy to decode the question or understand the question using diagrams. Why? After this point, you know a lot of geometry, right? Clear? You can use whatever the things you learned in O-levels to solve this. After that, you forget vectors. Think about a parallelogram. Think about all the things that you know about a parallelogram. Okay, all the other questions, you can use laws you learned in O-levels which are related to parallelograms. So that's why I explained that it's difficult to do these questions. So just try, but it's all okay if you can't get the answers. I'll explain this, okay? This exercise 3 is really important, okay? So it's just at least go through the questions and try to draw the parallelogram. That's enough. So in these questions, sometimes the maths we know is not enough, but when you turn the vectors into a parallelogram, after that you know a lot about parallelograms, angles, lot of things you learned in O-levels, right? So you can try to implement those things when you draw the diagram. So sometimes the best option is not to use the equations. Sometimes drawing the diagram is a better option. Clear? Sometimes drawing the diagram is a better option. Clear? Why? Then you know a lot of things related to diagrams. You learnt a lot of things related to diagrams in O-levels. So even though you don't know enough about vectors, your knowledge about diagrams you can use here, right? Clear? It would be helpful, right? Clear? So find its magnitude and the angle between two vectors. So now it's quite easy. Why? If this is root 3f, this is root 3f, right? This is a parallelogram. And if this is maybe gamma, I'll take this angle as gamma, then I can write sine gamma equals root 3f over 2f, right? Clear? Sine gamma, consider this angle, this triangle, consider this triangle, sine gamma equals root 3f over 2f. Clear? So I get root 3 over 2. So what is gamma then? Sine root 3 over 2 means gamma is 60, right? Gamma is 60, right? Sine 60 is root 3 over 2, right? Now they are asking the angle between two vectors. What is the angle between two vectors? This is the angle between two vectors, 90 plus gamma. So theta is 90 plus gamma is 60. So you get 150. See, draw the parallelogram, and sometimes the question is really easy. Clear? Clear? So you can use Pythagoras and find the resultant R. If this is the resultant, use Pythagoras law. Clear? R squared plus root 3f squared equals 2f squared. See? 2f squared. Clear? Clear? R squared equals root 3f squared equals 2f squared. Now you can solve this and find R, right? See? Now you don't have to use the equations. See? So for some questions, okay, I'll explain these questions again. Okay, I just wanted to give you a brief overview about that the equation, using the equation is not the only option always, okay? Sometimes using the equation, it's easy to use the diagram than using the equation, okay? Clear? Sometimes it's easy to use the diagram rather than using the equation. Clear? So you have to carefully choose which method to implement. Then okay, I'll give you like 2 minutes to write this down maybe. Okay, just let me know what is the class you have at 7. Then I'll check what I can do. Okay, then one more thing. Okay, allow me like for 1 minute, please be silent. I have to explain this again because some students asked. So give me 1 minute to explain this again. So this is a vector parallelogram. Attention everyone. Please be silent because some students are listening. I know a lot of you guys understood this, so please make sure that you are silent. Give me 1 minute to explain this. This is vector A, this is vector B. I put it into a parallelogram. Then this is the resultant. Then I complete this diagram. Then if this is B, this is B. Why? This is a parallelogram. So if this is B, this is B. Then if this angle, attention, please be silent. If this is theta, this is theta. If this is theta, this is theta. Then this length and this length I can take using B and X and Y. X becomes B cos theta, Y becomes B sin theta, Y sin theta equals Y over B, cos theta equals X over B. Then R squared equals this squared plus this squared. Why? This is a Pythagoras triangle. Okay? R squared equals this squared plus this squared. Attention, stop talking. So this distance is now A plus B cos theta. This distance is B sin theta. So squared of A plus B cos theta plus B sin theta squared equals squared of this one. Then I expand this. A squared 2AB cos theta plus B squared sin squared theta. B squared cos squared theta plus B sin theta squared. Then I have A squared 2AB cos theta, B squared cos squared theta, B squared sin squared theta. I write this, then this, attention, then I take B out and write cos squared theta plus sin squared theta, which is 1. I remove that because it is 1. Then I get A squared plus B squared plus 2AB cos theta. Then I get the square root. Then after that, so this is the magnitude of this diagonal, which is the resultant. All I used was this triangle because it is a 90-degree triangle. Then tan alpha is this length divided by this length, which means B sin theta over A plus B cos theta. So I know the magnitude of the resultant and alpha angle. That means I know the resultant, everything about the resultant. Clear? So today's marks, Ovina Samaratunga, 13. Then we have more 14s, because I think there are some more 13s after changing the marks, I think. Yes, right? Yeah, a lot of. Then Dison Pereira, 14. Situka Tarun, 14. Dinara Hettiarachi, 15. Tisul Ransana, 15. So the highest marks. Yeah. So, okay, I don't even look like 19, Luivar. Okay. I mean, that means smaller than that. Okay. So the plan, next week holiday then. Week after that, for now the plan is 3 paper starting at 3, class ends at 7:30, paper discussion 7:30 to 8:30. I'll inform everything in the group. But if you have issues, stay after the class and let me know. Anyways, I'm providing the recordings of whatever the parts you're going to miss. Yeah, so that's all for today, and thank you. Just make sure that you go through the points, try some questions. Next week, I'll first do exercise 3. It's a really important exercise. I'll finish all the questions in exercise 1, 2, and 3 before moving further. So make sure that you at least go through the questions and try them. Thank you.